Whereas language that talks about hexities or whatever is, it covers everything that really is, but it covers a load of other stuff that it shouldn't, because that stuff doesn't exist. Okay? So we can move from L indiscernibility, that is indiscernibility in a language, to indiscernibility simpliciter if the language is expressively complete. We can move from L discernibility to sorry, what have I said that right? Oh right, sorry, yeah, we can move from L indiscernibility to indiscernibility if the language is complete. We can move from L discernibility to discernibility if the language is sound. So obviously, if we have an adequate language, the idea is we can do everything in the language that tells us everything about the world. We can move back and forth between the two. Anything that's indiscernible in the world is indiscernible in the language, discernible in the world, discernible in the language. Everything holds. Okay, so now consider three kinds of language. So I'm painfully aware of the fact that I was billed as hating metaphysics. This is philosophical logic, actually. So, the first kind of language is where we just have a purely qualitative language. It doesn't include the identity predicate and it doesn't include any constants. The second kind, we add a constant for everything in the domain. And the third kind, we add the identity predicate but no constants. And then what we're going to be interested in is what can we say about discernibility in these different languages and how they relate to each other. Let me just say something about this idea of identity involving. Right? So in the literature you get people saying that properties and relations are qualitative if they're not identity involving. But I don't know if anybody has pointed this out, but it's not. There's more than one kind of identity involving, okay? And they doubly dissociate. So the kind of the distinction I have in mind is as follows: there's involving the identity relation, and there's involving and not doing so, and there's involving the identity of a particular object and not doing so. Okay? And these are different, and I can give you an example of a property that to put in each box so you can see they doubly dissociate. Okay? So what involves the identity of a particular object and the identity relation? Well, that would be a hexity. So the property of being identical to Mars, the planet, right, that's both identity involving and involving the identity of a particular thing. The property of being on Mars involves the identity of a particular thing, but it doesn't involve the identity relation itself. The property of being a sibling involves the identity relation, because you need to be able to say X is a sibling just in case there exists a Y, such that Y is a child of the same parents as X, and Y is not identical to X. Right? But that doesn't involve the identity of any particular thing. Right? And then if you just take property like red, say, okay, that's there's not identity involving in either sense. Okay, so qualitative language is going to mean not identity involving in either sense, right? Language with constants is not identity involving in either sense. Language with the identity predicate doesn't necessarily have constants, and therefore needn't be identity involving in the sense of having properties that refer to particular things. And that's an important point I'll come back to. Okay, now, and then, lest you thought that was all too simple, then we can start thinking about, yeah, what about if we start doing discerning in languages where we have some constants but not all of them? Because I haven't considered that case. I've only talked about having all the constants or none. But you can imagine just sprinkling a few constants in and then seeing what you can do. So I won't prove everything that I say now, but you can show that weak discernibility in a purely qualitative language is equivalent to absolute discernibility in the richer language that results from adding a constant for every object of the domain. Now, I think this is grist to the mill of people who want to criticise the Saunders approach to quantum particles satisfying PII. Because they say at the start of their paper, of course, if we're allowed individual constants, we can kind of discern everything, right? Because you can then say, well, look, that's particle 1 and that's particle 2, so they're not the same, right? But weak discernibility in a language with no constants means you've already got enough structure there that if you had constants, everything would be absolutely discernible. So weak discernibility in a purely qualitative language is equivalent to weak discernibility in a language that helps itself to singular reference to every object. We've proved that weak discernibility is in fact the most discerning non-trivial discernibility relation that's available. And so I'll tell you how you could try and do better. And I can't prove for you now, but if you're interested, I can send you our paper, and I'll say you that paper's good later on. You might have thought, but you've only been talking about two-place relations, right? What extra can you do if you're allowed n-place relations, right? So I've got two objects that I want to discern, but I'm now not only going to use two-place relations to discern them, I'm going to try and use relations that have places for other objects. And it turns out it doesn't give you anything more than weak discernibility does with two objects. And that's not trivial, I think. Now, there's another important point. It's not true that adding the identity predicate trivializes all the notions of discernibility, as I think Tim Williamson claimed vociferously to me when I gave a paper about this in his presence. So, what are the logical relations between these different forms of discernibility? Well, each of them is less discerning than the next, and weak discernibility is less discerning than numerical distinctness. Okay, so that might be obvious, but let me give you some examples. So graph theory is neat for doing all this kind of stuff. So if you just take an edgeless graph with nodes A, B, and C, then they are not even weakly discernible, but they are numerically distinct. If you have a two-node graph with an edge, then you now have weak discernibility, assuming that your graph isn't, you're not allowing loops. If you have if you had a graph like this, then you have relative discernibility but no absolute discernibility. Okay, so you might think that if you add in constants, then all the discernibility relations will collapse to the numerical distinctness relation, but that is not so. And the reason for that is that adding constants is not the same as adding hexaties. So just because I add constants to name individual objects doesn't mean I add predicates. In order to have hexaties, I need constants and the identity relation. Okay. So if you consider the edgeless graph with two vertices, then A and B are not even weakly discernible. If you add names for them, they're still not weakly discernible. There are no predicates that you can make. There's no predicate such that basically what you want, and there's nothing like that. So adding constants is not the same thing as adding hexaties. So what I'm trying to say is, neither adding the identity relation nor adding constants trivializes it, and they're different things. Where people have I think, run them together to some extent and talked about adding identity-involving stuff. They haven't distinguished between adding names for individuals and adding the identity relation. And adding either of them is not the same thing as adding both. And adding either of them is not the same, they're not the same as each other, obviously.